I'm going to use the graphing calculator to look at um, projectile motion. And projectile motion is usually written as a parameter because you have general equations um, to determine the projectile's height and length. And so a couple things that you have to do. First of all, in the mode, it's whatever the angle is, often it's degrees in this particular case, and parametric mode. And now when you go to y equals, notice that you have x sub 1, y sub 1. So this is in terms of t. That's parametric form. So all of this is from a formula that is projectile motion. It's in this particular problem, it talks about 35 feet per second as the starting initial velocity, and the angle at which it's kicked is 48 degrees. T refers to time in seconds. And notice that the cosines go with x's and the sines go with y's again, which has been consistent on the unit circle back in the trig unit. And on the second one, it's again 35, the initial speed, the sine of the angle, and then 32 refers to the gravitational pull, 32 feet per second squared, and the 2 is the initial height. So there's a formula there that I'm plugging that in. Now, when I go ahead and graph this, what I'm going to want to do is go to the window, and the window is in some sort of a mode here from before, and I have to think about what these mean. Now, the t refers to seconds, and so I'm going to go from 0 seconds, and I'm going to think, how long does that take for that ball to be in the air? Maybe 5 seconds. And the t-step is how often do you want that plotted, which makes sense to be something very small like that. The x-min and x-max, that's how far it travels, and I'm talking about feet here. So let's say they can kick it, I don't know, 100 feet as a guess. So that's going to go from 0 to 100. And x scale is fine. And how high is it going to go? Let's say from 0 to 50. These are just guesses. And now that's how far each click mark is going to go. Now when I go to graph, it's going to give me a general idea of what that looks like. And I don't like what that looks like, so I'm going back here and I'm checking to see, is there a mistake on what that graph is all about? And there isn't a mistake there, so I'm going to go back and look under my equations and see if I can see anything in terms of my equations on where I went wrong. And let's see. There's a plus sign there, and that's where I made a mistake. So that should be a multiplication sign. And now when I graph it, hopefully that fixed the problem, which it did. And now I can get a better viewing area because I know it's going to be less time, and I'm a little bit high on both of those. So maybe 70 would be a better length, and maybe 30 would be a better height. And let's see if that makes a little bit better graph, which isn't too bad. It's getting there. One more switch should get into maybe a little bit better viewing area, 50 and let's say 20. That looks pretty good. Now, you can do a lot of things here. You can determine what the maximum point is. So you could always trace and figure out what that is. Now on the tracing, when you go to window, you can really get a smaller step when you do this, and therefore when you trace, you're going to hit more points as you go along and have a better answer. So when you hit trace now, you're going to see that it's going to go up by a lot smaller amount, and you get whatever point that you want. In terms of calculating, not a lot of options on calculating. At 2 seconds you could put in and it's going to give you your X and your Y if you wanted to. But the other thing that you could do is go to the table, and the table, when I go to table setup, I can go and ask on the X. And so when I do that, or the T value, if I go to 1, it can give me my X, Y, and I can really answer a lot of questions by fine-tuning my T on guess and checks, depending upon what you want. Like if you want to know where it hits the ground, that's going to be at 0. I could think, well, let's see, that could be 2 is too much, so 1.8, getting closer, 1.75. Well, you could kind of sit here all day and still not get the right answer, but you can see that I'm getting closer and closer, so it's more like 1.72, 1.7, about 1.69 or 1.68 will get you very close, and that will tell you the distance at which it traveled before when it hit the ground. So you can play around a lot with the graph and use the table ask function, which is really nice. And this is a nice visual because it's showing you really the path of the ball. It shows you the height and when it hits the ground. So parametric equations on the graphing calculator.